Okay, word problem here for 2.4 absolute value equations. A machine fills Quaker oatmeal containers with 32 ounces of oatmeal, and after those containers are filled, another machine weighs them. If a container weight differs, it doesn't say specific, it just says differs from the desired 32 ounce weight by more than 0.5 ounces, then the container is rejected. Write an equation that can be used to find the heaviest and the lightest acceptable weights for the Quaker oatmeal container. Very good, very good, very good. So 32 is what we're looking for here. 32 in a perfect world is what it is that we have going on here. So when I take a look at solving for the equation here, that 32 is kind of sort of the jumping off point for me. And what I'm going to do in terms of that equation is go x minus 32. Y minus 32. Again, I'm trying to consider what would happen if I were to zero that out. Now, the way that we differentiate this kind of sort of what the point of no return, if you will, is we cannot go outside of the 0.5 ounce realm either way on the high end or the low end. And you might even know this number already without setting up that equation. But I have an absolute value bracket set equal to a positive number, albeit a small number. So I know that I would have two scenarios here. What I see, and then of course, what would happen if instead of a positive 0.5 in the bracket, it would be a negative 0.5 in the bracket. Well, I would add 32 to both sides, and I have 32.5 for one x value, and for the other x value, I would add 32, and I actually get 31.5. So here, when I solve this specific equation, and I set it up, I get two solutions, which I expected because it's set equal to a positive number. B value here, or excuse me, the B question, if you will, is write all the acceptable weights from the container as a compound inequality. Now, those are kind of sort of our barriers. So if I need to write this out as a compound inequality, I do want to go small to large. And so the smallest solution that I got was 31.5. 32.5 is my biggest possible amount that it can weigh without having to get it rejected. And I am allowed those actual responses. So as a compound inequality, those would be all of the possible solutions that I could have for this scenario. And of course, 32 is ideal, but I could go 31.6 or 31.7 or 32.3, somewhere in that mix. It's going to be okay. The container would not get rejected in that green amount. Anything outside of it, 30, 35, those are problems, and that would be something that would get rejected.